Yeah, it's very exciting. As I've mentioned, that's the first in-person seminar after, I believe, February 2020. So good to be kind of back in person and seeing a lot of faces here. So I'm very excited to have Dr. Erick Wikum as our speaker today for the first analytics seminar for this semester. Dr. Erick Wikum is currently an analytics consultant at Wikalytics LLC, but he has a nearly 30-year career, and his previous work experiences include diverse technical and leadership roles at Tata Consultancy Services, IBM, Schneider, Norfolk Southern, and the US Air Force. Dr. Wikum has earned MS and PhD degrees in operations research from Georgia Tech and a bachelor's in operations research and mathematics from the United States Air Force Academy. He is an active member of Informs, having recently served as the president and subdivisions council's representative of the Analytics Society, and he's an associate editor of Journal on Applied Analytics, Informs Journal on Applied Analytics, and he served on the organizing committee for Informs Business Analytics Conference for a number of years, and it's also the general chair for the 2022 conference next year. So very excited, and thank you again for accepting our invitation, and today he's going to tell us about practicing analytics in target-rich environment.
Thanks, Chris. All right. Well, thanks for the welcome that I've had today. I really enjoyed meeting a number of you and speaking with you. I have a daughter who lives across the river, and she works for a large retailer that's headquartered here in Minnesota, in Minneapolis. And to her, this title means a little bit different thing than it does to me. But this is something that I've been saying for quite a few years that predates her, so I have the right to use it here. I want to just share a little bit about my journey. Chris mentioned my background in academia. When I graduated from Georgia Tech, I was in the Air Force as an Air Force Academy graduate. And so during the 4 years when I was at Georgia Tech, I earned my PhD, and I was also promoted from second lieutenant to first lieutenant and then to captain. So I show up at Scott Air Force Base, which is in Illinois, not too far from St. Louis, and I got a real lesson in humility the first day that I got there. A major said, "Captain, come with me," and we went to a conference room where he was briefing a general, and my job was to go in the back room. This was BPP, before PowerPoint, and I got to flip slides. So when he said, "Next slide, please," then I got to take off the one and put the next one on. So I was newly minted PhD, captain in the Air Force, and I got a lesson in humility for sure. After I left the Air Force, I went to work for Norfolk Southern, and that's where I met Darren England here, and we worked together. And so I was there for about 5 years working in the Industrial Engineering and Operations Research Department, and that's one of the areas that is really interesting because railroads have a lot of different moving parts, and there's a huge number of different types of problems to work on. After I left Norfolk Southern, I joined Schneider, which is a transportation and logistics company headquartered in Green Bay, Wisconsin. And I was there for about 10 years doing a variety of roles, including a director within the engineering group. So I got some leadership experience as well as doing a lot of technical work focused on many different parts of the business there. So after I had been at Schneider for about 10 years, I looked at my career and I was seeing that I was kind of very comfortable, but I wasn't growing as much as I wanted to. And so I decided it was a great time for me to leave and go out on my own. So I formed a company called Freelance OR. I left in August of 2008, and in September of 2008, the whole world fell apart. You remember the Lehman Brothers failure and the whole financial crisis. So for 18 months, I tried to find work with various companies. Most of them were just trying to hold on to their employees at the time. They weren't interested in someone who wanted to offer consulting services, and frankly didn't really know exactly what it was that I was offering to them. So after 18 months earning a little over $30,000 with 3 kids to feed and a mortgage to pay, I decided I better do something different. So I joined IBM, and at that point, IBM was really hiring ahead of the curve. They knew that the recession was going to end and that they were going to have opportunities to sell analytics to companies. So they hired a lot of talented people who were available in the marketplace and put together a big team. And so for the first 6 months there, I didn't have much to do. I was so-called on the bench waiting for projects to come. But after that, I never had a chance to come up for air. So after I left IBM, I joined Tata Consultancy Services, and I was there for about 3.5 years. And I was actually doing more of a research, but I was working with a supply chain group and working in the applications that they had. So back to 2017, I had a chance to again go out on my own, and fortunately, this time worked out much better. And I've been at that now for more than 3 years here, going on 4. So it's been a very good environment to find work in this area that we call analytics. This is one of the things that I look at in terms of my career, many different experiences, many different companies, different cultures, is that I really value the diversity of the experiences that I've had. I think one of the things that we need to be careful about is people who look like they go someplace for a year and then decide they're going to switch and switch and switch, and someone says to themselves, why would I hire this person who I'm going to train them and then they're probably just going to leave my company just as they left these other companies? So I have a 3-year rule. If you're going to go work someplace, give it at least 3 years. Maybe it'll improve if you don't like it, but at least you'll have given it a try. And then I think, especially in consulting area, there's a saying that consulting is a revolving door. In other words, consultants often leave one consulting firm to go to another. So anyway, I look at my career as being a very diverse set of experiences, which is valuable to me in being able to offer many different things that I've learned from many different. But again, I also look at this thing about switching, and I know some people who have stayed in the same place, and there's some benefits to that as well. So let's look at these terms, the OR and analytics. And these definitions are from Informs, in case you're not familiar with that. It's the Institute for Operations Research and Management Sciences, a professional organization. I'll be saying a few more words about that eventually. But they define OR as application of advanced analytical methods. So they have analytics kind of built into that definition. And this is an important thing, is to make better decisions. So their focus is, I guess, first of all, the name Informs was chosen because it suggests that we're informing somebody about something, and that who we're informing is people who make decisions, and we're trying to help them make better decisions. The definition of analytics is fairly similar. In this case, they added scientific process as well. But again, the focus is insight for better decisions. So if you look at really what happens in a business, a decision doesn't do anything. Like, I'm going to build a new factory. That doesn't make it so, right? So a decision which is informed by data has to be implemented. And the decision can be good or bad, or sometimes you don't know because there's uncertainty if it's going to be a good decision until the end, but it has to be implemented. So we should also have some interest in implementation and making sure that when we help a decision maker make a decision, that there's follow through to make sure that that decision, whatever it is, gets implemented well, because even a good decision implemented poorly can turn out poorly. And then the organization will achieve some results. So this is kind of the chain. Use data to inform decision makers. They decide, but then it needs to be implemented, and then you can see what the outcome is. And this is something that's very important, is to focus on decisions that matter. There's a whole lot of problems in the world to solve that are probably very fun to solve, very challenging to solve, but in the end, they may not make much difference to anyone. So my druthers is to find problems where at the end of the day, it can change the way somebody does something, it can change the decisions that are made and have a positive effect. I like to think of seeing my fingerprints and knowing that something that I did actually led to some kind of success. So these are several ways we think about monetary things usually, but there's also looking at service within an organization, service to your customers. And then that last one, saving lives, is really, it's not just saving lives. It could be improving service at a hospital or helping people in a variety of ways in their lives. So when we look at problems, first of all, it costs money to hire somebody to do analytics work. It's not free. So when you do it, you need to make sure that you're prioritizing and choosing problems to address that really can make a difference. So what does a target-rich environment look like for practicing analytics? I think there's 4 ingredients. The first one is that there's either a complex problems that that an organization faces, or a real diverse mix of them. And often large-scale operations are a really great place to operate. Let me go back to the previous slide here briefly. If you look at large-scale operations, they often involve many, many decisions, and the impact of any one decision is maybe very small. It might be $1 or $5 or $10, let's say. But if you make many, many, many of those decisions, then by improving the quality of each one, you can have a large impact. The other type of decision are strategic decisions that are made only very infrequently, but they have a huge impact. So for example, if Intel decides to build a new fab plant that costs $10 billion or more, and there's lead time of years to do all the planning and everything, that's a huge decision. And just deciding when, where, and how to build that can have a huge impact just in that one decision. So when we look at decisions that matter, we might see this case where it's few really big decisions or many, many smaller decisions. So back to this. So in the large-scale operations, like dispatching drivers to truckloads, each of those we can't have a huge impact, but these companies do thousands and thousands of these things and millions of them over the course of a year. Another thing that's needed, fortunately, this has advanced a huge amount over the course of my career. When I first started, like, data was not readily available. Now with things like the internet and sensors and so on and so forth, there's a huge amount of data that's available. It's not always the highest quality data, but there generally is a lot of data available. And it also may not be exactly the data you need in some cases. That would be a challenge there as well. But in an organization where you're looking for a target-rich environment, you want to see an organization that has a lot of data available to you. And then when you look at that, do they have a lot of different decisions that they're making? And these questions, it's interesting. I'm not going to go into it now, but when you think about a decision, it's a question that somebody's asking. When am I going to do something? How am I going to do it? Who's going to do it? Where is it going to happen? These are the types of decisions that you see. And you also, helpful when you're thinking of these questions to know how to recognize where decisions get made in different processes as you're looking at them. And then the last thing is to have the support of management. There may be all these other things aligned, but if the management isn't on board and supporting, championing the use of analytics to address the problems that the organization faces, then it may be a frustrating experience. So that also needs to align. Fortunately, this kind of advent of analytics, if you look back at things like Moneyball, and there was a book called Competing on Analytics that was published, there's a lot of people who have seen what this can do and they're interested in it. So we probably aren't going to see a whole lot of like huge resistance, but it's more a degree of the support that management gives to analytics within their organization. Now I'm going to share with you two different industries where I've done some work. And first I'm going to talk about kind of from a high level, what are some of the things that make that a target-rich environment for practicing analytics. And then I'm going to share with you a specific example of something that I've implemented. So one of them is agribusiness. There's a local company here, Land O'Lakes, that's in this. There's also some big players like Bayer, Syngenta. I can't remember the name. Dow DuPont has kind of something in this, but their companies have split and renamed, so I'm not sure exactly what the name of that is. But in terms of that, this business involves a lot of providing seed for farmers, as well as chemicals that can provide relief from insects and other things that would damage the crops and keep them from growing. So in terms of that, there's a whole lot of different operations first of all, there's a whole research pipeline of developing the next generation seeds that are going to be grown and whatever types of characteristics that or traits that these crops are going to have. So that involves a lot of science, but there's a lot of opportunities for analytics work there to improve processes and help them better select which of the hybrids should be promoted to ultimately be sold to customers. There's also large-scale growing operations. So these companies actually have to plant seed to harvest seed. So the seed that the farmers get has to actually be grown itself. And so there's a whole lot of problems logistically and other things around how much of each seed to plant based on their projection for demand. There's also just when should they plant in each of these regions, when should they harvest it to get the maximum amount of seed yield from that. So in terms of that, another thing is pricing. If they look at it generally, the larger the buy or the higher the price they pay for seed. And there's some marginal farmers who wouldn't ordinarily buy, let's say, a high-end product because they can't afford it, but it might be priced right for them so that they can actually buy it. So that's, in general, the pricing gives a break to more marginal farmers and charges farmers who really have good productive land and so forth more. So there's a lot of work that needs to be done in trying to figure out, is there a way to figure out things like price elasticity and so forth there. This environment is really interesting because there's uncertainty both in the supply and the demand. So first of all, what's the demand going to be next year for this seed that I've never grown? Some of it I've grown before, others I'm having new products. How much of it should I grow for that demand? And then second, there's uncertainty about when I plant that seed. I don't know exactly if I'm going to get as much yield from that as I think I am. So when the weather turns poor, I might get a lot less seed than I had planned, even though I had the right number of acres planted for that. And then the other problem in terms of data is that they really only get one data point per year, because they wait for crop to grow, and then they can get some yield data from it. So if you want to put together a data set that has like 30 or 40 years, good luck, because most of these hybrids don't last that long. And you also have to worry about a hybrid and the environment in which it's grown. That changes how it will yield. So those are some very difficult problems to address in terms of being able to forecast yield for different hybrids. Yes?
So the customers here are the farmers?
Ultimately, they're growing the seed for the farmers that the farmers are going to buy. And some of these companies sell them through dealers, so they don't actually sell it directly to the customer. They sell it through dealers.
But the company would not buy back the harvest from the farmer?
No, the farmers, well, in this case, most of these crops are for sort of, I'll call it industrial consumption, not human consumption. So corn, for example, is used for livestock, and it's used for ethanol production. And so most of these are not the kind that you grow sweet corn or what have you for human consumption. But the farmers are growing it either because they need it for their operations, for example, to feed livestock, or they sell it in the market either for other farmers' livestock or for ethanol production. So they're the ultimate customer that they have to think about when they're creating these new products. Okay, so this is an application. If you think about it, let's say you're a farmer, you've got a number of different fields. Maybe those fields are like different in terms of their soil, possibly in terms of their topography. One of them might be flat, and another one hilly, and so forth. So the question is, what hybrid should I buy for these fields that I have? And you can think of that as a portfolio optimization problem, because what the farmer ultimately wants is yield. They want a lot of, say, corn to be produced, and they need to pick which of these hybrids should go in each of those fields. So in terms of that, just like financial portfolio optimization, there's this diversification that if I choose a mix of hybrids and not just one, that I might have a chance of mitigating the risk of a poor outcome, because one of them might do poorly, but another one might do better. And generally, just like financial assets, the higher the return or the higher the yield, the more risky it is. So yes, you can achieve this high yield with this hybrid, but you might also have the risk of having a commensurately lower yield. So in terms of this, we were able to develop something that would say, these are the fields that you have, here's the size of each field, and here's the mix of hybrids that you should plant, or at least consider to plant in those fields.
So the farmers don't have capabilities to implement optimization on their own?
Typically not. There are some really large commercial farms that might.
So they are, who's the solution provider here?
There's a couple ways of looking at this. If you look at these agribusiness companies, they produce seed, so that's a product. They produce chemical treatments, that's a product. But they're moving into this area of being able to provide advice to farmers who face, I think it's something like 70 decisions that they have to make throughout the year. What crops, what types, specific hybrids of those crops or varieties, when do they plant, when do they harvest, when do they detassel, and are they going to dry the corn in the field, or are they going to dry it later? So there's all these decisions. So that's another area now, is to provide services with the data to help farmers do better with your products.
I suppose there are app-based platforms that the farmer would enter their characteristics and the app will suggest courses of action. Is there such a thing?
There is, yes. Yeah, there's a company called Climate Corp that was bought by Monsanto, now Bayer, that offers a lot of, and it has it's actually an in-cab solution that will help them figure out like planting densities within a field and a lot of other things. So this sort of, you could call it precision agriculture. The reality is that there are a lot of challenges, either with the data that's not available or that, but it's heading in the right direction, and there are definitely some capabilities in the marketplace for that. Okay, so next thing I want to talk about, which is where I spent a lot of my career, is transportation, supply chain, and logistics areas. These things, you have operations going over both time and space, and so there's a lot of complexity. As you're moving over time, you got to determine when these things are going to happen, and things like, are we going to take this load or not that could send a driver here or there? How are we going to get this driver back home when they need to get back home? Which crew are we going to put on this train? So there's a whole lot of different types of decisions to be made. And you could also think of things that happen within, sometimes they call it the four walls. So you have a warehouse maybe with material handling equipment in it, and how is that going to function? How are you going to design it? How are you going to test it out to make sure it can function before you actually build it? And then there's things that are more like involving the transportation between different locations. So there's a lot of different aspects here. You can lump probably manufacturing into this as well as part of the supply chain. So that has all problems of getting raw materials to it, and also the actual operations to manufacture things. You also have to decide, what are we going to manufacture? How many of these types of cars or those types of cars are we going to manufacture? So when you think of these questions, if you say where and when, you think in terms of what we do. There's sourcing, like which suppliers should you go to based on where they're located, routing and scheduling of drivers, of trucks, of rail cars, and of containers, of chassis, all these different types of equipment and resources that need to be moved around in the network. And then how are we going to do something? So for example, which mode are we going to use? Are we going to send this shipment using small package or less than truckload or rail or ocean freight? So sometimes it's obvious, sometimes there is a choice to be made, and you need to look at the cost and the service as well as that. So let me share an application in this area that I did. Hopefully some of you will learn something new here in terms of the word dray. How many of you know what dray means? Okay, so in what's called truck rail intermodal transportation, there is a trailer or container. These days, a lot of it's being done with a container that's delivered to a shipper empty. And the shipper fills that container, and then that container is hauled by a truck to a railhead. And then a crane lifts the container onto a rail car, often double stacked. And then the train takes them kind of on the long haul between locations. At the opposite end, there's the container comes off the rail car, and it gets trucked to the consignee location or the receiver of the freight. So these moves on either end, either from the shipper to a railhead or from the railhead to the consignee, are referred to as dray moves. If you think about that from the standpoint of, let's say, a series of rail ramps. So for example, in the Chicago area, there's a lot of railroads operating there. So there might be half a dozen or more rail ramps. So out of each of those rail ramps, you got some moves that are inbound coming from the shipper into the rail ramp to be sent out on rail. And you've got other things where they're being railed into Chicago. Now they need to be trucked to Indiana or Wisconsin or wherever something is bound. So you've got these moves that look like they're going to the rail ramp, and you got some that are going out of the rail ramp. And the idea is that you've got a set of drivers they start their day at a certain place and at a certain time, and they can work, say, roughly 12 hours in a day, and you've got to assign them which of those moves are you going to do. And based on how you assign that, you can be much more efficient or less efficient in terms of the number of miles that you have to do, whether or not you deliver something on time or not. And so in this case, we put together an optimization model that made recommendations to dispatchers as to which load should be assigned to which drivers. And one of the challenges in this is the sometimes called change management. How do we get people to actually use this tool? So that was a challenge, especially people who think they really know what they're doing. I don't need you to recommend things. I know how to do this. So that was one of the challenges that we had to overcome, which goes beyond just math and data. How do we solve a people problem to get this actually implemented and effective?
What's different about the different products?
Generally, they can all do most everything. Some of them may start at different places and they may work slightly different shifts, but they pretty much are fungible in terms of being able to be used any way we want them to be used. If you string a set of loads together for one driver, it can be efficient because, for example, from the end of one, they may be able to go to another one without too many empty miles between it and then get another one. So one of the things that we saw is something called triangulations, where somebody takes a load from the ramp, drops it, and then goes to a shipper and gets a load and brings it back to the rail ramp. So there are efficiencies in kind of driving out empty miles. One thing that I didn't mention here is that they also had to look at, okay, when you leave this place, do you have a trailer or container in tow? Because if you go to this other place, you're expected, let's say, to have a container and even a chassis, which fits under the container on wheels to make that. So there are rules about which ones can be done that are not trivial, so the optimization can put together things that work from that standpoint as well. You may have heard recently in terms of the supply chain, there's all kinds of woes, a lot of them brought on by the pandemic. So for example, you see these headlines that I've captured here. Right now, there are 70 container ships stacked up at the Port of LA. Usually there's 10 or less. And so all of those things that all these merchants have ordered for Christmas and so on and so forth are going to be sitting there waiting for enough people to do it. There's a problem with enough people at the port. There's enough problem with enough drivers to actually pick up those things and move them. There's problems in overseas markets where people are having COVID and factories are having to shut down. If you go into stores these days, you'll probably, especially like a grocery store, you'll probably notice some empty spots on the shelves. So bottom line is we've got some serious woes here. So what could we do from an analytics standpoint to help this? One thing I think is that in the name of your school, it's called Industrial and Systems Engineering, isn't that correct? Systems, you may not even talk about systems that much, but it's really important to think of the supply chain as a system and everything in it interacts. So in this case, we really want the supply chain to produce throughput, right? We want the things that need to get shipped to enter the supply chain and come out the other end being available for us as consumers. But in that supply chain, there are bottlenecks, and we have things like simulation. I mean, we can just measure or analyze data to see, in these cases, we know where some of the bottlenecks are. We know that some of it's related to people getting sick. We know some of it's shortage of workers in various areas. So this is an area where, again, your ability to think through a system from end to end in your head and think of it as a system and not just this piece and that piece can help to solve big problems like we have here. So, for example, you may test a hypothesis that if we were to change this, it could help to improve it at least a little bit. But maybe through some modeling or data analysis, you might be able to prove that out, figure out nobody's going to solve this overnight. We might have this problem for the next couple of years, hopefully not, but it may be there. But it's people like you who can go out and at least help identify ways that we can start improving this and turning it in the right direction. I want to shift gears a little bit now from talking about these applications to some of the lessons that I've learned through the years. And one of the things I've figured out is that it's all well and good to be good about how to deal with data and have mathematics at the ready to be able to analyze things, know how to create effective, let's say, graphics and so forth. But there are a lot of other things. I mentioned one of them, which is there are a lot of people problems where people stand in the way of you being able to implement things. And I say that kind of facetiously because we don't look at people as being the enemy, but they can be hurdles. And if we can get over all of these hurdles, including the people, and implement something and have success, it's a real reason to celebrate because it's not easy to clear all of those hurdles. So one of the things that I like to say is if you want to have success with analytics, it's not just what you do. And by what you do, I refer to as, I chose to create an optimization model and I use this data and these constraints and this objective function. So that's one of the things, in terms of the technical things that you do, but how you do it. So what does how you do it include? Well, one of things is, have you worked with someone who can be a champion for the effort to make sure there's support for it in the organization and funding for it? Have you sort of taken stock of who stakeholders are and whether they support it or they're against it, and what you might need to do to try to turn them in the right direction to support what you're doing? Another thing is, are you ready to provide a budget? How much is this going to cost? How long is it going to take? What is it that you're going to produce on the other end? So all of these things, putting together a project plan and executing that project plan. It's not analytics, but it's essential to be able to be successful with analytics. The other thing I've found is that when you're in school, it's kind of like a fire hose. You all know that. You're taking all these different courses and you're learning all these different things, and it's all well and good, but it's really hard sometimes to retain everything and really grasp it firmly like you would like to. And so sometimes you have to just sort of learn enough to do well on the test and hope that you have an appreciation and maybe can loop back sometime in the future to understand that better. So that's what I call learn it and you know it. But what I found, especially when you get into the working world and you start using these things, then for one thing, necessity is the mother of invention. So let's say you're not that familiar with forecasting. Maybe you took a course or two, but you're not really thinking of yourself as an expert. Well, if somebody gives you a project, then you will figure out what you need to know about forecasting. And when you use it within a project and you're kind of forced to learn it at the level to apply it, then you will own that. You won't forget it after that once you learn it in that environment. So what I'm not suggesting is that you not try to learn what you're seeing now, but this is kind of the reality that often these applications are where it really reinforces that knowledge and makes it necessary to the point where you really understand it and you really know how to use it. All right, the next thing. When I was a young analyst, I kind of said to myself, well, I'm I'm an operations research analyst. I'm not a computer science major. If I wanted to know how to program really well, I would have been a comp sci major. But I've since learned that the better that I am at coding and understanding various computer science things about architecture, data structures, a lot of other things, the more I know about that, the better I can be as an OR or analytics analyst. So the bottom line is that I'm encouraging you to make sure that you not only learn about things like optimization and simulation, but you learn things about, for example, databases or Hadoop or other ways to wrangle data, also ways to different coding packages that you might be using. And the more you learn about that and the better you are, then the better you'll be at what is your primary role as an analytics or OR analyst. Okay, the other thing I learned, remember when I said that I tried in 2008 to go out on my own? There were a lot of things I didn't know. And I don't think even if I knew all of them, I would have been successful just because the economy was so terrible. But one of the things I learned when I worked for IBM, and especially when I was on a project with about 100 people on it, and that was just the IBM side, the client had more people, but I got to see all kinds of consultants at work, and I learned so much from watching them do what they did. So what does it mean to be a consultant? So one of the things I mentioned just earlier, well, you use some discipline in what you do. So you put together a project plan. The alternative to that, I have down in the corner here, is just do stuff. That's what I think a lot of companies do. People just launch into things and they do it and they don't know exactly what they're trying to accomplish. They don't know the time frame that they're shooting for. They don't know how long it's going to take. But with a more disciplined approach, you know what that is. One of the most important things for a consultant is deliverables. What is it that you're going to be delivering? And being specific about that, not just saying, well, we're going to put together something to help you improve this. But it's like, what is it going to be? Is it going to be a model? Is it going to be a tool? Is it going to be some kind of analysis that we're doing to help you with that? Another thing that consultants do, as opposed to doing stuff, is that they put together either proposals or ultimately statements of work that carefully define what it is that they're going to do. And that's what they get paid for. That's kind of the contract with the client. So what I found is that if you work for a consulting company, these things are things that you know about and you learn about and you practice. When you work inside of a company, most people don't think of themselves as internal consultants, but that's really what you are. And you should learn these consulting skills. And even though you could get away with just doing stuff, by being disciplined about your approach, you'll be more effective and help the organization more and also exhibit what you can do as a consultant better than you could if you just do sort of an undisciplined ad hoc approach. Okay, this is another thing that I suggest. When I first started, I really got into transportation logistics. Specifically, I think the first thing that I really sunk my teeth into was railroading. So I wanted to understand things like, what are the concepts around railroading? How does it work? What are the terms that are used? How can I provide good examples? If I'm talking to somebody from the business, then can I give them a good example of something that has them say, oh, you really know what you're talking about? So initially in your career in practice, I would recommend choosing a industry vertical that is something that looks appealing to you and really proving not only that you can do analytics well, but that you can grasp that and provide feedback to business people there that they value. Then later, you can look at more of a horizontal which is basically saying, oh, analytics, OR, these things apply almost everywhere, in every industry. So a problem is a problem. We can model things kind of generically, and whether it's a financial portfolio or an agriculture portfolio, it's really very similar, but the terms are different and so forth. So as you move into other industries, again, go back quickly, learn what are the concepts, what are what's the terminology, what are the competitors, what kind of topics are hot in this industry right now, and then you'll be able to move across that. And I've found that to be really rewarding, first to confirm that what we do really applies to a lot of industries, but second, to be able to come in quickly and be able to add value in some place that I maybe don't know much about at all. I'll finish with this point with a little story. When we were working for a oil company in Calgary, then we went in and we put together an optimization model and a simulation model. And we had to basically get a oil pipeline 101 course from some of the business people there, where they basically taught us all these things about how oil pipelines and terminals work. But then the friend that was on the project, he said, well, in phase 2, they're going to have to pay us a lot more because now we're experts. Okay, the last thing that I'm going to suggest to you, if you haven't already, is to join a professional organization. The home that I've had for the last close to 30 years is Informs. If you find another organization, then by all means join that. There's a number of different professional organizations that might suit your needs. In terms of Informs, there are student and geographic chapters. Is there a student chapter here by any means? Great. So if that's one thing you can do right away is join Informs and join a student chapter. And it's relatively cheap. I think it's like $36 a year to join Informs while you're a student. It's considerably more when you're not a student. And then another thing that they offer is called Certified Analytics Professional. There's also something called ACAP for Associate. And this is a professional certification. You get it by taking a test. And the CAP also requires that you have some work experience and that your boss essentially says, yes, this person has a certain level of experience. I don't know the exact definition of that, but you can find out about that. So that would be a great thing to have on your resume, that you're so-and-so CAP. And then another thing they offer are career fairs and a career center. So there's an online career center at the conferences that they offer the ability to link up with many different companies. And there's one coming up here in another month or so that was to be in Anaheim. It's kind of a hybrid conference right now, but even if you don't go in person, you would still be able to participate in the career fair there. And then there's another thing within that called pro bono analytics. One time someone asked me if they thought these competitions like Kaggle competitions and so forth were good. There's a lot of people who like to compete in that and then put that on their resume that they won such and such a prediction competition or what have you. And I suggested that this is an opportunity to think about. So this is a group within Informs that looks to nonprofit organizations who could benefit from analytics but don't have the wherewithal to provide that. And so they can present their problems to Informs, and then several Informs members who are volunteers can help them do that. So to me, that would be an excellent thing to have on your resume. It's a real project, and it's helping out a nonprofit organization in the process. So with that, let me open it up to questions. I think we've got about 10 minutes left here. If anyone has any questions, then.
Kind of going back to your point about being a consultant. Obviously, when you work in a company, you get kind of familiar with key stakeholders and kind of who's going to be a proponent for some of the work and the change management. when you're a consultant, how do you identify those stakeholders and kind of their roles in the project kind of early on?
Are you referring to like as an external consultant who comes in and doesn't really know the organization? Well, I think one of them is that the person who was involved, person or persons who were involved in actually retaining the consulting company, can be resources to help you understand the lay of the land within that company. And then I guess it takes time to meet the people, but a lot of consulting companies work with clients longer term, and the best business that a consultant will ever get is repeat business. That means you did a good job, they want you back again, and you don't have to do much to bring that in. It's a whole lot harder to find clients to begin with. So I think there's that it's more challenging if you're not in the organization and kind of know the people, but I think there's a few ways that you could do that. Any other questions? Yes.
So in the case of the agribusiness, so you mentioned there is actually very, very few data points, probably one data point per year. Right. So I'm just wondering, how do you deal with this very limited number of historical data?
I'll say a couple things. One is that in South America, they actually have 2 growing seasons, so you can get twice as much, but that still doesn't help you that much. If you want like, let's say 30 or 40 data points, you're still not going to be there. So one of the things that in the US, there is some county level average yield data. And the USDA, United States, I'm losing it, Department of Agriculture, collects data from farmers, but then aggregates it and publishes it. So they know the actual numbers that the farmers reported, but that would not be available to anyone. So what is reported is a county level average yield. And you can really try to do something with that. I worked with a group of statisticians that were looking at that very problem. It's very difficult to solve, but you basically have to figure out how to kind of creatively take the limited amount of data you have and try to turn it into something meaningful. So that problem is not well solved. If you look at papers that have been published, that's what almost everybody says is lack of yield data is a major problem.
Yes, you could experiment, right? You could plant things in different ways, using different seeds, applying different amounts of chemicals, whatever, and then see.
Yes, they do have test farms that some of the big producer or the big companies have, but even those, it's still quite expensive, and so they don't have a huge amount of data. They do also have data from greenhouse where they grow these things, but the problem there is that the conditions are kind of ideal, so they don't necessarily reflect the experience that farmers would have planting in the fields. One of the things I wanted to, go ahead.
You just mentioned 2 different stints that you've had now as kind of founding a company, a consulting company, and how the second was more successful than the first, and obviously one big reason was timing. The timing of the first one was just not at a time when companies were interested in that sort of service. Do you think that's the main one, or are there other things that you've learned or done differently the second go around that you would kind of attribute to it being more successful?
That's a good question. Let me go back to that slide that I had here. So first of all, just in terms of timing, there was nothing I could have done that would have changed that. So that was the first thing. But when I joined IBM and then also TCS, I learned a whole lot about being a consultant, and that helped me a lot to be successful the second time around. So coming out of that, I had worked inside several organizations, fairly laissez-faire environment. I'm not criticizing them. I'm just saying that that's the way a lot of organizations are. They don't use a very formal process. They like I said, they do stuff. And they get some results, but they not necessarily because they're doing it in a great way. So that was one of the things. The other thing is that, I mean, I don't have a website. I don't sell anything to anyone. I primarily have developed a series of contacts over the years, primarily working for a few companies, but also consulting companies where I can subcontract with them. So if you were to look at going out on your own, I think there's two things that I would recommend. One is it's helpful to have a cash pile so that if work doesn't come in right away, you can survive for some period of time. And that might be right at the beginning, or it might be in the middle where you finished one project and nothing else is appearing for a while. So depending on your needs at your point in life, having maybe a year's worth of cash available to be able to survive. The second thing is having the connections to provide it. And there's other things that you might develop some kind of a software program that does something. So that's completely different. That's not what I'm doing. I'm doing just varied consulting projects across different organizations. So I don't think it necessarily means that you can't do that, say, straight out of school and try it. But those two things I think are useful to be able to survive in that. And the people that I know who, they know me, they know what I do, they know to call me, and fortunately some of them have. But establishing those contacts over a period of years is put me in that position, I think.
So what does that typically involve? What does it mean to be involved in a consulting project? Is it identifying problem? They come to you with a problem and then you help formulate, I mean, we're OR people, right? You help them formulate it as an optimization problem? Solve it, implement it, or you just look at the data? Or what is it? What is the value add you bring?
I've been involved in a whole gamut of things, and some of them are perhaps, like, if I look at it, it's not the most exciting thing to me because the content of things that I would enjoy doing, like maybe creating a mathematical programming model or something like that, is not there. In some cases, I created a spreadsheet that was fairly complicated in terms of the calculations, but for all of you here, it wouldn't be any great shakes to be able to put something like that together. But I got paid for it and I needed a project, so I took that, and it was fulfilling because the client really appreciated it and they needed it. In some other cases, I've had more flexibility to, I had one role where I was actually able to just direct which problems I would be working on, working with the person. So it wasn't that they said, we're hiring you for this project and this is what you're going to do. But I've had some others that are pretty tightly, you're here to create this. And some of those have been optimization problems where I had to go in, understand the data, and talk to some business people and really understand what it was that they were trying to achieve, and then put together kind of a prototype and share it back with them, and then ultimately deliver that. One of the things about being inside of a company is that you can often stay with something for a period of years, because sometimes ideas take a while to mature. When you're a consultant, sometimes you have to just leave, like your part is done, you're gone, you have no idea what became of this. I had one where I was gathering requirements for an optimization model, but I wasn't actually creating the optimization model. And I did a review meeting with the client. They said, yeah, that sounds like if you create a model like that, that's what we want. And then I left. And I don't even know if they finished the project or if they were successful with it, if the client used it, no idea. So sometimes it's a little difficult with that of not being able to kind of follow through and see what happened with the contribution that I made. But I think there's, like I said, there's some good meaty problems that I would really enjoy working, but at the same time, you kind of got to fill in sometimes with some other projects that may or may not be exactly in your sweet spot, but in some sense, if people will pay for them and they want it and it can add value, then even if it's not highly appealing to me, then I'm willing to do that. I'll say one final word about consulting is that when you look at a project and someone says, we want you to do something, you should feel a little bit of fear, and that fear is, boy, I don't know everything I need to know to solve this. But at the same time, you have to basically say, this is something I think I can do. I'm going to have to go learn this and this and this, but I can do it in this time frame and deliver it. But at the same time, you need to be able to walk away and say, no, I'm not an expert in this. I'm not going to do this for you because I want you to find someone who really is an expert who can help you with that. So that's also something that builds trust with the customers if you're willing to say no to them.